Welcome to Chemistry Lover, and from today I am going to start a new video series which will be named as the Reagent Chemistry, and every week I will post one or two videos on a particular reagent and their uses. What are the uses of the reagent in the organic chemical synthesis? So that will be discussed in this video. And in today's video I'll be talking about a very well-known reagent, which is the metachloroperbenzoic acid. Now, what is the necessity of these videos, or what are the benefits of watching these videos? So by watching these videos you will get to know a lot of reactions within in only one video, so that will be very helpful for you. And in this video I will discuss the brief mechanism of all the reactions. So this will be a revision for you for the reactions which you already learned, and you will get to know the use of the reagent. So that is the benefit of these videos. So now, without further delay, let's start today's topic. So if we talk about metachloroperbenzoic acid, it is a very common and well-known reagent, and the first reaction which will come to your mind is the Baeyer-Villiger oxidation. And you can see I have written here the Baeyer-Villiger oxidation, which is nothing but the oxidation of a ketone to the corresponding ester. So you can see this ketone is oxidized to this ester. And if I write down the brief mechanism of this particular reaction, you can see, so the mechanism will be, so let's say this is R dashed, and now you have the metachloroperbenzoic acid. So this is R, this R group is basically the metachlorobenzene group. Now first of all, this will be protonated, right? So this will be protonated and this will be minus, or as the reaction is occurring in the acidic medium, this will also be in the OH form. Now what will happen next? So this will attack here and it will open. So if this happens, you will get this thing. So this type of tetrahedral intermediate you will get, and here you will not have the positive charge, so you will have the free OH group. Now when this oxygen lone pair will push, so the R group which is having the more migratory aptitude, for example, let's say here this R dash has the most migrating aptitude over this R, so it will be migrated here and this will go as a leaving group. So you will get this as your ester. So this is the mechanism, and this R O minus, this is the leaving group here. So this R group is basically this one, this metachlorobenzene group. So this is the brief mechanism of the Baeyer-Villiger oxidation, and here you just have to worry about the migrating aptitude of the R groups. So this is first reaction. The next reaction which should come in your mind is the Preliship's reaction or the epoxidation reaction of alkene. So this is again very simple, and you can see this is a example of the Preliship's reaction. And if I write down the mechanism, so it has a concerted mechanism. So here I can write like this. So basically this is like O, this is H, this is another oxygen, and this is this R group. Now this alkene will attack here, this bond. So from the alkene pi electron cloud, the attack will occur here. This bond will break and this electron will go here, and this will take this proton, and this again will come here. So it is a concerted reaction, and out of this you will get this epoxide, and here the leaving group is this acid. So this acid is the leaving group, and you will get this epoxide product. So this is again a very well-known reaction, and you know, if you have something like this where you have a OH group and this is a chiral center, so then what will happen? On which phase the OH group is there, from that phase the reaction will occur, or from that phase the epoxidation will occur, because this OH will have a hydrogen bonding with this epoxidizing agent. So this thing you have to remember. Now based on this reaction, this third reaction is related to this pre-Lipschitz oxidation, but it is called the Optim oxidation. And here, starting from a silyl enol ether, you will get, so basically it is protected SiR3, so you will get this silicon protected alpha hydroxy ketone. So what is the mechanism? The mechanism is very simple. At first, the pre-Lipschitz oxidation will occur on this alkene. So let's say this is your OSiR3 group. So when it will react with this mCPBA, in the first step what will happen? This pre-Lipschitz reaction will occur. Right, now you have this OSiR3 group. Now this oxygen lone pair will push and this will open. So from that you will get this OSiMe3 or SiR3. Here you will have a positive charge, and now you have O minus over here because this is broken. So now this O minus can attack on this silicon and it will break. Right, so from that you will get this OSiR3 and here this oxygen. So this is how you will get this alpha hydroxy ketone, right? So this is again very simple. It is further modification of this pre-Lipschitz oxidation, or you can say the pre-Lipschitz oxidation is related to this. Now the next reaction is the oxidation, and you can see in, so basically metachloroperbenzoic acid is a good oxidizing agent. So it is a mild oxidizing agent, so whenever some oxidation is needed you can use it. So here you can see this sulfide, it is a sulfide where the sulfur atom is here and it is oxidized to the sulfoxide. So if you treat this with mCPBA, it will be oxidized to here, and it is basically the attack. So basically like the same way here also, as the pre-Lipschitz reaction occurs, the same way this sulfur lone pair will attack here and it is oxidized to this. So you can also think it like O minus and S plus. So you can see if the sulfur oxygen lone pair attacks on this oxygen, it will be like S plus O minus. And now the another resonance canonical form is this, and we can write it because sulfur has the d orbital, so it can form this extra bond. Same reaction is with amine. So it is a tertiary amine, and when it is treated with mCPBA, it is oxidized to amine oxide. Same reaction. So more other oxidations are also there, but these are the 1, 2, 3, 4, 5. These are the 5 main reactions of the metachloroperbenzoic acid, which you must know, because from these reactions only the question comes in the exams, and these are also useful for your practical organic chemistry. So that's all. I hope that this video will be helpful for you, and if you want more videos like that, subscribe my channel. Thank you for watching.